Welcome to the lecture on graphing lines. I'm going to talk about two different methods for how to graph a line, and you want to make sure that you know how to do both methods very well. The first method that I'm going to talk about is the intercept method, and that's using the x-intercepts and the y-intercepts. Well, the x-intercept is found by finding where y equals to 0 and solving for x, and the y-intercept is found by plugging in x equals 0 and solving for y. Then you just graph these two intercepts on your x and y axis and connect the two intercepts with a line. So I'm going to show you two examples using this method. Suppose that we have the equation 3x minus y equals to 2. If we want to find the intercepts, then what I like to do is just create a little table where I let x be 0 and y be 0. If we let x be 0 in our initial equation, we're going to substitute in 0 for this x right here. So that would look like 3 times 0 minus y equals to 2. And 3 times 0 just goes to 0. So we end up with negative y equals to 2. And if I divide both sides by negative 1, that tells me that y must be negative 2. Now, I showed a lot of work to figure that out, but a lot of times you can just imagine putting your thumb over this x term because it's going to completely disappear, and then you can just visually see what y would have to equal. If we let y be 0 this time, we're going to substitute in 0 for this y, so you're putting your thumb over that y variable and seeing what x would have to be. If we substitute in that 0, all we're going to have left is 3x on the left and 2 on the right. Now you can just visually see the solution to that, or algebraically that would just require dividing by 3, and so x has to be 2/3. So these two values that I got here are my intercepts. These are 2 points on my line. 0, negative 2 is called the y-intercept, and 2/3 comma 0 is called your x-intercept. And so now to actually get the graph of our line, we just plot these 2 points. 0 comma negative 2 is at negative 2 on the y-axis. That's why it's called a y-intercept. 2/3 comma 0 is going to be on my x-axis. Since 2/3 isn't a nice whole number, you're going to have to approximate where that would be. And 2/3 is just a little bit less than 1. So here's 1, so 2/3 I could estimate it to be about right there. Oops, sorry about that little stray mark. Now once we have our 2 points, we just connect them with a straight line, and there's our line, and we're done. So let's try that again with another example. 4x minus 5y equals to 20. If we want to use intercepts, it's easy to just make a little xy table and find where x is 0 and where y is 0. And you can do a lot of this in your head, but I'm going to show you all the written out work for this. So first we're going to let x be 0. So I'm going to substitute in 0, or you're going to put your thumb right over that x term. If I put my thumb right over that x term, this whole x term goes away, and all we would have left is negative 5y equals to 20. And what would the solution to that be? Well, if I divide through by negative 5, that forces y to be negative 4. So my y-intercept is 0, negative 4. Now we're going to do that all over again, but this time we're going to let y be 0. So you're going to put your thumb over the y term, and it's going to completely disappear, and that would leave me with just the 4x and the 20. And if I divide both sides by 4, that forces x to be 5. So 5 comma 0 would be my x-intercept. Now we're going to plot these 2 points. So 0, negative 4 is at negative 4 on the y-axis. 5 comma 0 is at 5 on the x-axis. And I'm just going to connect the 2 points with a line, put your arrows on, and you're done. Okay? Now we're going to redo these 2 problems all over again, but we're going to do them in a different way, using a different method called slope-intercept method. Now this method is requiring the use of a slope and a y-intercept, and we're going to find those 2 things by taking the equation of the line that's given to us and putting it into slope-intercept form. You've probably heard of this before. It has a very special look to it. It looks like y equals mx plus b. where m is your slope, which we're going to think of as rise over run, and b is going to be our y-intercept. So the first thing we're going to do for this second method is solve our equation for y, get the y all by itself, so we can identify what that m and that b is. Once we have put it into this special form, we're going to identify that b, which is our y-intercept, and that's what we're going to plot first on our y-axis. Once we know a starting point, that y-intercept, then we can use our slope and think of it as rise over run to count out our next point. So that's going to be how we get our second dot. Once we have our two dots, we connect them with our line and we're done. So here's what we do to begin with. We want to take our equation and we want to put it into y equals mx plus b form. So that requires getting y completely by itself. Now there's many ways to do that. I'm going to just show you one method. If we start with 3x minus y equals to 2, to try and get y by itself, the first thing I might want to do is move this 3x over to the other side. I can do that by subtracting it since it's already a positive 3x. So that would make these cancel out. On the left side, make sure you notice you're going to have that negative still in front of your y. That hasn't gone away. And on the right hand side, we have 2 minus 3x. Those are not like terms, so you're just going to write those side by side. Now I happen to like putting the x term after the 2, but you could also have this in an opposite order. You could have this written as negative y equals that negative 3x plus 2. Either way is correct. If I finish solving this for y, that's going to require getting rid of this negative, and that's like a coefficient of negative 1. So to get rid of a negative, all you have to do is divide every single term by a negative 1. And all the effect that that has is changing all your signs. So this negative y becomes positive y, positive 2 becomes negative 2, and negative 3x becomes positive 3x. And you could do that equivalently over here. I'm just going to do it once. So here's my final form. It has the x term coming second. That's okay. All we need to realize is that the m is the coefficient of that x term, no matter where it goes. So here our m is 3, and the b is the constant, the term without the x. So here our b is negative 2. Once you've identified those two things, the first thing you want to plot is that negative 2. That's your y-intercept. So that's the point you're going to put a dot on the y-axis. So I want to go to my y-axis and put a dot at negative 2. Now to graph a line you need at least 2 points, and so far we only have 1. So to get our second point, we're going to use that slope, and we're going to think of it as rise over run. In order to think of it as a fraction, rise over run, you want to take that 3 and write it over 1. So think of it as 3 over 1. So this means we want a rise of 3. Since that's positive, that means we're going to rise up. And then we want a run of 1, and since that's positive, that means to the right. So from our starting point where that b was, at negative 2, we're going to rise up 3, 1, 2, 3, and then over to the right 1, and that's where we're going to put our second dot. And once you have your 2 points, you connect them, and there's your graph. Okay, let's try that all over again with this second example. So we have 4x minus 5y equals to 20, and remember we're trying to put it into y equals mx plus b form. So we need to get this y term by itself. So the first thing we're going to do is move the x term over to the right side, and since it's a positive 4x, I'm going to subtract it. So that's going to give me negative 5y on the left, don't forget your minus sign, and on the right I'm going to have 20 minus 4x. Then to finish solving for y, we want to get rid of that coefficient by dividing, so I'm going to divide through by negative 5 in all 3 terms. So here the negative 5's cancel out, giving us just y. 20 divided by negative 5 is negative 4, and here do a little bit of reducing. A minus divided by a minus becomes a plus, and this just can be written as 4/5 x. Push that x off to the side. So remember, the coefficient of x, the number in front of your x, that's your slope m. So that's what we're going to think of as rise over run. And this is already written as a fraction, so it's ready to go. The constant on the end that didn't have an x, that's your b. So here, -4, that's my y-intercept. So when I go to plot my line, you have to start with that b first. So we're going to go to -4 on the y-axis, 1, 2, 3, 4, put a dot. And then from there, we're going to use our rise over run. This is a +4 rise, so that means go up, and a +5 run, that means go right. So we're going to go up 4 and to the right 5. Put a dot, and now we have our 2 points, connect them, and we have our line. Okay? We'll practice this one more time, but before we do, we're going to take a look at 2 special case lines. The next example, we want to graph the line y equals to 4. And this should look a little bit strange because there's no x term at all. And what that means is that there's no slope, and a zero slope. There's a 0 in front of that x. So what this is a special line, and you want to just basically memorize this fact that we have here a horizontal line, and every horizontal line is always of the form y equals to a constant. There should be no x variable at all. And horizontal lines have 0 slope. There's no x term because its coefficient is 0. So all we have to do is recognize that when we see y equals 4, that's just a horizontal line at a height of 4. So you go up to 4 on your y-axis, and you just draw a horizontal line at a height of 4. And that's it. You don't need intercepts, you don't need slopes, you just recognize that it's a horizontal line. In contrast to that, the next example just has an x. So if there's only an x variable and no y variable, that's the other special case of lines, and that would be a vertical line. Every vertical line is always x equals to a number. And this has no slope. All vertical lines have no slope or undefined slope. So all you have to do here is recognize that this is a vertical line. Go to -2, this time on the x-axis, because we want x to be -2, and just draw a vertical line at -2, and you're done. Okay? In our last 2 examples, we're just going to practice one more time graphing these lines, and I'm going to do these in a couple different ways. So this first one here, 3x minus 2y equals to 6. When I see a line in this form, this is actually called standard form, where you have a constant a times x plus by equals to c, where the x and the y are on the same side of the equation. If you have a line in this standard form, a good method to use is the intercept method, because that doesn't require as much work as solving this for y to figure out what that slope and that y-intercept is. So when I see a line in this form, I tend to always just go straight to my xy table and find those 2 zeros. So if we have 3x minus 2y equals to 6, and I want x to be 0, I'm just going to take my thumb and place it over that x term because it's going to disappear, and what I would be left with is that -2y equals to 6. Don't cover up that negative that's in front of that 2y. It should still be there. And then look at what's left here and figure out what your solution would be. This is going to force, if I divide through by -2, it forces y to be -3. So that, remember, is your y-intercept. 0, -3 is my y-intercept, where x was 0. Now we're going to do the opposite. This time we're going to cover up y with our thumb, and what we would be left with is just 3x equals to 6. And you can visually see the solution to that probably without doing any work. Here we're going to get x is 2. And that's called your x-intercept, so 2, 0. So all I have to do to get my line is plot these 2 intercepts on my axes. 0, -3 would be right here, and 2, 0 would be right here on the x-axis. Connect them with my line, and we're done. Okay? Now in the next example over here, I don't have that standard form. The x and the y here are kind of on opposite sides of the equation. So if that's the case, then I may be more likely to try and convert this into that slope-intercept form. So I'm going to solve this or graph this line by finding the slope first and that y-intercept. And I do that by solving this equation for y. So if I start with 15 minus 3y equals to x, to get that solved for y, we want to get the y term by itself. So I'd want to subtract this 15 over to the right side. That's going to leave me with a negative 3y equals x minus 15. And then to finish solving for y, I'm going to divide through everywhere by negative 3. So these cancel out, giving me just y. And right here, I want you to be careful. This coefficient that's in front of the x is an implied 1. So one thing that I like to do when I see this x over negative 3 is I rewrite this as a negative 1/3 and push that x off to the side. And then when I have a minus 15 divided by a negative 3, a negative divided by a negative always becomes positive, and 15 divided by 3 is 5. So what I end up with here is this new equation equivalent to the original one, but now it's in that slope-intercept form. The coefficient of x is my slope m. So negative 1/3 is my rise over my run. And this constant on the end is my b. That's your y-intercept. So when I go to finish solving this or graphing this line, you want to start with that y-intercept first. It was at positive 5, so I'm going to go to the y-axis and put a dot at positive 5. And then for my rise over run, I have negative 1 over 3. Now I chose to put that negative in the top next to the 1, so that would make my rise be negative 1. Since it's negative, it's actually going to force me to go down 1. The run is a positive 3, so that means I'm going to go to the right 3. So this slope means go down 1, right 3. So from my b, I go down 1, right 3. Now just to show you here, if instead I had put that negative in the bottom instead of in the top, then I would have a positive rise of 1, which would tell me to go up 1, and my run would be negative 3, which would tell me to go left 3. So let's try that. Starting at that b again, this time I'm going to go up 1 and left 3. Notice that it gets me a different point than the one I had before, but when I connect my dots here, they're all on the same line. So it's not necessarily going to give you the same point you would have gotten if you had put the negative in the top, but the end result is the same, and that's all we care about. We want to make sure that we're getting the right line. So here's my final line. Alright, so make sure you are able to graph lines using these two different methods, intercepts and the slope and y-intercept method. Good luck. That concludes our lecture on graphing lines.